Okay, so dividing rational expressions, our next lesson. So the dividing rational expressions is going to be a whole bunch like multiplying rational expressions, um, where you virtually multiply straight across. But when you're dividing, there's one little trick to make this a little bit easier, and that's that's how you handle the second fraction. When you're dividing by fractions, if you recall, if you were to flip the second fraction and change it to multiplication, you get the exact same result as if you were to divide it. So we're going to employ that exact same strategy, where we can change to multiply and then use all the same strategies we used before. We just need to flip that second fraction. Then you multiply straight across and simplify. So in this case, we've got a 2 and a 4. We can simplify those to a 1 and a 2, a 3 and a 9. We can simplify those to a 1 and a 3. And that would equal 1 times 3 is 3, and 1 times 2 is 2. So simplifying fractions, simplifying division fractions, or simplifying the division of fractions, just means flipping that second fraction and multiplying. There is a proof as to why this works, but we're not going to go into it at this level. So if we're flipping this second fraction, then what really matters for the non-permissible values is going to be the numerator, or sorry, the denominator of the first fraction and the numerator of the second fraction. Those two values are the ones that we're going to pull our non-permissible values from. So let's try one with some polynomials, with 4 sets of binomials. So again, the non-permissible values from this list are going to come from the denominator of the first fraction and the numerator of the second. So non-permissible values, we want to find out what would make this 0. So not in, x minus 5. We want to find out what would make that 0. We can do that by solving for x. Add 5 to both sides, and you'll find that if x was 5, that would make this 0. And again, because we're going to flip this fraction, and effectively this numerator is going to become the denominator, our second set of non-permissible values is going to come from the numerator of the second fraction. So let's solve that one for 0 to find out what wouldn't work there. So you add 2 to both sides, and 2 and 5 would make this whole equation divide by 0. 2 or 5 would make this whole equation divide by 0, and that would give you an unreal number. So actually solving and simplifying this, let's flip that second fraction and change it to multiply. So x plus 6 over x minus 5 times x minus 2, x plus 4, x plus 4 over x minus 2. And then we can combine those together and we get x plus 6 times x plus 4 over x minus 5 times x minus 2. There's nothing in these that is simplifiable, so you could turn these in, either leave these as binomials, or you could multiply it out and expand it out to get your trinomials, depending on what format your question is asking you to end it in. So this is an acceptable answer, but you could also expand it. So x times x would be x squared. X times 4 is 4x. 6 times x is 6x. And 6 plus 4, or 6 times 4 is 24. All over x times x is x squared, x times negative 2 is negative 2x, negative 5 times x is negative 5x, and negative 5 times negative 2 is plus 10. Combine together your like terms, and you get x squared plus 10x plus 24 over x squared minus 7x plus 10. So again, depending on the format, it's asking you to answer your question in either leaving it as the binomials or expand it out into trinomials. These would both potentially be acceptable solutions to this division. Now we can go a little bit more difficult than just dividing binomials. So when you're steps to deal with this, when they're more complicated, factor all of your expressions. So you're looking for a couple of things, looking for a common term between them. So say 2x plus 4, you could simplify out a 2 there. Or if you have a trinomial, you can break it into two binomials. And then always look out for the infamous difference of squares, a perfect square minus another perfect square. That would convert into like x plus minus the square root of your number. So factor all of your expressions. Then you're going to reciprocate the second expression and multiply. State all of your non-permissible values. Remember that is going to come from the denominator of your first number or the numerator of your second number. Or sorry, and the numerator of your second number. And cancel out any common factors that you may have in the numerator and the denominator to get your simplest form. So, so let's do this one. So x squared minus 9. This is difference of squares. So let's turn that into, this is a perfect square minus a perfect square. So it's going to be x plus the square root of this. Square root of 9 is 3 times x minus the square root of that second term. So x minus 3. And if you were to expand that out, you get x squared minus 9 over. So we're going to need to find two terms for this trinomial. We're going to need to find two terms that multiply together to give you 4, but add together to give you 5. So 4 can be made with 4 times 1 or 2 times 2. The only way you can find a sum from these that give you 5 is through the 4 and the 1. And since it's a positive, it's going to need to be positive 4 and positive 1. Since there's no coefficient, those are just going to be what your terms turn into. So x plus 4 and x plus 1. And on to this one up here. So we are going to reciprocate this. So shouldn't use the x. We're going to reciprocate it and turn it into multiplying. So this is going to come into the bottom. So let's factor the one on the top and see what we're going to get for our denominator. So we need two factors of 3 that would add together to give you 4. 3 is a prime number, so there's only one combination, and 1 plus 3 would give you 4. So again, no coefficient here, so that these are just going to be what your two terms turn into. So x plus 1 and x plus 3. In our oh darn, those are supposed to go down here. My bad. In the denominator now is going to be that last one. So again, no coefficient, so we're just looking for multiples of, factors of 12 that can add together to give you 7. So your factors of 12, you can have 1 times 12, 2 times 6, and 3 times 4. The only combination that will give you 7 is the 3 and the 4. It's all positive, so plus 3 plus 4. So x plus 3 and x plus 4. So again, this numerator became the denominator, so it's the factors of this that will give us our non-permissible value list, including the denominator for the first one. So it's these values and these values that we need to pull our non-permissible values from. Once we've reciprocated and factored it, it's these terms and these terms here. I'm just going to erase those lines so we don't confuse them to be something else. So our non-permissible values, we need to see what would make each of these four terms equal to 0. We have two x plus 1s, so we only need to do that once. So let's do x plus 4. We want to see what would make that 0. So you solve for x by subtracting 4 from both sides. And if x was negative 4, that would make this 0. So x plus 1, find out what would make that 0 by subtracting 1 from both sides. And negative 1 would make either of these two 0. And one last one, x plus 3 is equal to 0. Subtract 3 from both sides to find that x cannot be negative 3. So our non-permissible value list is negative 4, negative 3, negative 1. Now let's have a look. So these two are going to combine together, multiplying straight across. So we can look for anything in the numerators and see if it's shared with anything in the denominators, and they would cancel out. So we have an x plus 3 in the top and an x plus 3 in the top and the bottom. We have an x plus 4 in the top and an x plus 4 in the bottom. And we have two x plus 1s and x plus 3 and an x minus 3 left over. So there's nothing further we can do there. So x plus 3 times x minus 3 over x plus 1 for our final answer there. Oh, sorry, we have two x plus 1s. X plus 1 times x plus 1. And our non-permissible value list is negative 4, negative 3, negative 1. All right, so we are going to do the same thing here. We have a difference of squares here that we're going to want to deal with. And we have a common term, a c here, that we want to factor out. And then two trinomials that we're going to want to factor into two binomials. So let's do them all. So equals, let's do this one, the numerator of the first fraction here. We want to find two numbers that multiply together to give negative 7, but add together to be negative 6. So our factors of 7, it's a prime number, so our only option is 1 times 7. The only way to get negative 6 from this is a negative 7 plus 1. So with no coefficient here, we don't need to decompose the middle. It'll just turn into these two. So we'll have c plus 1 times c minus 7 over. This is a difference of squares, so it's going to be c plus minus the square root of this. So the square root of 49 is 7. So c plus 7, c minus 7. And now we're going to change it to multiply. And so this numerator is going to become the denominator. So we're going to need to find we're going to need to factor this trinomial. No coefficient here, so we don't need to decompose the middle. So let's look for factors of 7 that can add together to give us 8. 7 again is prime, so 1 times 7 is our only option. So if we add these two together, that would give us 8. So it will break into the two binomials c plus 1 and c plus 7. And doing it again, it goes in the denominator. So c plus 1 times c plus 7. And the last one there, we can pull a factor of c out of these two terms. If we pull a factor of c out, we would be left with c plus 7. All right, look for anything in the numerator and the denominator that are shared, and we can simplify those out. Or, sorry, first let's do our non-permissible values, our non-permissible value list. So the numerator here and the denominator here, those factors are the ones that we need to make equal to 0 to see what would make this whole thing equal to 0. So this plus 7, this minus 7, the plus 1, and the plus 7. So we've got 2 plus 7s, we'll need to do that once. So let's do the plus 7 first, our non-permissible values. So find out what would make that 0. Subtract 7 from both sides, and negative 7 wouldn't work. Let's do the negative 7 next. So c minus 7 equals 0. If you add 7 to both sides, c can't be 7 either. And then we'll do the 1. So c plus 1, what would make that 0? Subtract 1 from both sides, and negative 1 wouldn't work. So negative 7, negative 1, and 7 is our non-permissible value list. Now let's simplify anything from the top and anything from the bottom that are shared. So we've got a c plus 1 and a c plus 1. We have a c plus 7 and a c plus 7 and a c minus 7 and c minus 7. And we're left with a c over c plus 7. And that's as far as we can go. Don't be tempted to cross with these c's because this is c plus 7. If it was c times 7, you could cancel out the c's, but not if you're adding. So our non-permissible values was, from least to greatest, negative 7, negative 1, 7. Okay, 3 of them to combine together. So we'll do the same strategy. We're just going to have 3 things that we need to multiply together. We are just going to need to flip this second fraction here. So let's flip it and multiply. Let's see if there's anything that we can simplify first. The 3 and the 12 can be simplified by factoring out a 3. So if you factor out a 3 from the 3 and the 12, you're left with x plus 4. In the denominator, we'll need to do some trinomial work here. We'll need to factor the trinomial. This one does have a coefficient, so do the a times c. 3 times 12 is 36. We want to look for factors of 36 that would give us negative 5 if you summed them together. So our factors of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. The combination that can possibly give you the negative 5 is if you had the 9 and 4 together. So negative 9 plus 4 would give you this. So since you have this term here, we are going to have to decompose and then factor. So we're going to turn this negative 5x into positive 4x and negative 9x. So this would be 3x squared plus 4x. It doesn't matter the order that you put the 4 and the 9. You're still going to end up with the same result. Minus 12. Group the first 2 terms, group the second 2 terms, and add them. So from the 3x squared plus 4x, the biggest thing we can pull out is an x. And we're left with 3x plus 4. From the negative 9 and the negative 12, we can pull out a negative 3. And we would be left with 3x plus 4. From these 2 sets of terms, from the x times 3x plus 4 and the 3 times 3x plus 4, we can pull out that 3x plus 4 factor from both of those. and we'll have 3x plus 4 times what's left over is the x minus 3. And that's what goes into this denominator. So 3x plus 4 times x minus 3. Now we're going to change this to multiply. And when you do that, you have to flip this fraction. So there's nothing to simplify in these ones. So let's put the 3x plus 4 up here, and the 12 down here. And then we're still multiplying by these two. So 2x minus 6, they both share a factor. You can factor out a 2. So if you factor out a 2, you'd be left with x minus 3. And then in the bottom is just an x plus 4. Alright, so we are going to combine together all of these terms. You don't necessarily need to put them all together to do that. We can do it right from this form. So look for anything in the numerator and anything in the denominator that's shared. X plus 4 and x plus 4. There's a 3x plus 4 and a 3x plus 4. There's an x minus 3 and an x minus 3. And then 3 times 2 is 6. We'll do them one at a time. 2 and 12, they simplify to 1 and 6. And then 3 and 6, they simplify to 2 and 1. So what we have left on the top is a whole bunch of 1s, so 1 times 1 times 1 times 1 times 1, which is just 1. And in the bottom, the only thing left besides a bunch of 1s is the 2. So this is equal to 1/2 with our non-permissible value list of, oh, we didn't do our non-permissible value list. Needed to do it from here. Let's do all of our non-permissible values from these terms. So non-permissible values, we want to find out what would make 3x plus 4 equal to 0. Subtract 4 from both sides. Divide both sides by 3. And negative 4/3 would make this 0. Do the next one, x minus 3. Add 3 to both sides to solve for x, and 3 wouldn't work. Nothing to worry about with the 12. There's no x values that can change that, being just a number. X plus 4, though, we do need to find out what would make that 0. Subtract 4 from both sides to solve for it, and you get negative 4. So our 3 non-permissible values in this example is negative 4/3, 3, and negative 4. So from least to greatest, our non-permissible values would be negative 4, negative 4/3, and 3. And again, we simplified it to 1/2. That's all for this one. Thanks, guys.